Hello everyone, today I am going to deliver a lecture on influence line of frame. So firstly I will showing the influence line of frame, and then I will solve the influence line of frame using Müller-Breslau principle. So let's see influence line of the frame. Okay, here is a example. The frame structure. This is the frame structure, which is called is given below. So it is given below. So write down the equation for RA. So you have to equation for Rn. Sorry, it will be Rn, and draw the influence line of Rn, and then draw the influence line of BH, which is here, and MS, which is here, and MA, which is here. So let's start. So before I am going to deliver here, so I want to show that this is the inclined slope. We have been seeing here the reaction is given incline. So I'm just showing how can I sorry. Okay, I'm just cutting here this portion. I'm just cutting here, as we have been seeing. This is the inclined line. So inclined line, we have been know this is the incline. So that's why this theta. And if we using this line and putting this here, so it will be this theta. So this theta and this theta will be same. If we is here, so conjugate or opposite theta will be same as here. So in this way we can see this theta and this theta will be same, and this theta will be same. So vertically why I am taking the theta, as if I know the is a component, when the theta will be component, that will be cos theta. That's why we are saying here Rn cos theta, and another one is Rn sin theta. What is no, there is no theta. So okay, so Rn cos theta is a vertical portion. So you can see here the vertical portion 0.883, and the x-axis horizontal one in sin theta have been found here, and we also calculate the theta tan inverse 2 into 3, as the slope is given here. Okay, so now I'm going to the calculate mz. So I'm taking the moment in that portion. So Rn equal to 0.55. So I mean Rn to 0.55, and distance will be this distance. As we know, the distance is given here 15. The distance will be here, as we have been taking the this x-axis data. That's why it will be distance will be like this, which is 15.5. And vertical portion, we have been seeing here the vertical portion. This is the Rn into 83, this vertical portion, and this distance will be this 19.6 into 19.6. And another load we have been seeing here, the moving load 1 kip is moving over the frame. This is the x1 equal to 0. So as per we have been calculating here, so we have gotten this equation. So Rn equal to x divided 40 divided 9. So this is the x. So now we are putting the value of x and finding this result. I'm just taking a screenshot here. So we have been seeing here the we are moving this load for distance of s. This is the s. If we put the value of x, then it will be the value will be Rn will be 0. And similarly, if we use the x value is as 1, this point, as we have been taking the distance 19.5 into 19.5, which is 39, and the Rn value will be 0.9. And we've been taking the another x value, which is this is the s double prime, which is 39 into 20, and Rn value will be 1.10. And as u, if we calculate the u and taking the x is negative here, this here, then Rn value will be 0.25. So in this way we have been finding this. So this is the equation. So our first is show and write down the equation of Rn. So we have been completed this. Okay, so I'm just taking the our main figure for we have been going the next slide. So I'm going to the next slide for calculating influence line of array. As we've been seeing, we have to do influence line of array, our second question. So this is our picture. So I'm just taking here, and I'm taking here in the right side. This is our influence line we've been seeing here. So as we, if we taking the influence line of Rn, so we've been already shown here the we've been taking the loop, taking the point, so taking the value, all the value we've been found from this equation, as we've been seen x divided by 49 into 9. So x value we've been putting here 0.10, then we've been taking minus 10, then we've been found minus 24, so minus 24, and 95 we've been found when the x value is 95, then 95, and 1.44 we've been found when x is 59. So in this way we've been calculating xn. So our second question is completed. So now we will draw the influence line of bs, that means this, and m is this moment of here and moment here. So let's see how we calculate. So we have been seen, we are drawing influence line here. Influence line of Rn is mean horizontal. So if we are getting the value of horizontal, as we know Rn into 0.55. So if I going here, so this is the Rn equal to 0.55. So we have been seen here the Rf in 0.55. So we are getting the point. We are just putting here 0.55 into 0.24, the value of Rn. So Rn we have been doing the previously this diagram of the Rn diagram. So 0.55 and 0.24 minus 0.24, then it will be 0.134. So if we calculate a 0.55 and 0.95, then we have been found 0.52. In this way we have been calculated Rn into horizontal. So I will get this equation. We just equation getting from the calculation of the previous. So influence line of Rz, Rz vertical. This is the Rz in vertical. As we have been seeing, Rz is a vertical. So I will calculate. So we are simply just simply is taking the upward only. That's why its influence line will be like this. This influence line will be like this, as oh my god, sorry for okay. So if we take the Rz, this is the Rz, as we know Rz is here. So if we is pushing upward, then it will be going the upward also. So the influence line will be like this. So we are taking this here Rz, we've been just pushing here, then that's why one unit will be here, and an influence line will be like this. So Rz horizontal, how will get the horizontal? As we know the Rz horizontal. So Rz horizontal is the equation we have been found. Rz horizontal equal to Rn horizontal. That's why the two diagram will be same. Rz and Rz horizontal and Rn horizontal. These two diagram will be same as the horizontal are similar. So let's see another influence line of B, which is in this point B. So how will calculate? Okay, so we will calculating here. So P diagram we have been seen here. It will be Rz horizontal also, as the same as we have been taken the equation. Now we are taking the equation here. B, the B portion is here. I am just saying we are taking the B portion. So in the left segment, thus we are taking this left segment, as we are taking the horizontal and taking the ruler support is here. So you can see our vertical Rz is vertical, and another is here. So we are taking this moment is this portion. So for balance purpose we have been seeing the horizontal portion BHV. So it will be BHV equal to BRZ V. So that's why this two diagram will be same. Okay, so let's see another example we have been seeing here. We're getting the influence line of MS. Where is MS? This is the portion of S. So taking the moment here. So in the right segment we have been seeing this is the right segment. Taking moment in here as one key, and the value will be MS equal to x1. So x value is dependent. So if we put in x0, then MS equal to 0. If we put in the m50, then MS will be 50. So that's why it will 0 and 50. This diagram will be like this from this putting as we have been founding this here. This is right segment we have been taking this. So last one we have been seeing the influence line of MA. Here is the MA. We have been taking the moment MA. Sorry, it will be there MA. So just there is a two load we have been seen in the horizontal, which is RZ is, and another was RZ vertical. So if we taking the moment here, MA equal to RZ horizontal to 25.6 as the distance is given here, 25.6. Okay. So as per our we have been founding RZ is, where is RZ is, this is the RZ is. So if we just putting multiply with 25.6, then we found this diagram. So this diagram also is similar this diagram. Okay, so let's see another example here. This is taken from Professor Dr. Vikramanan sir, University of Dhaka, Bangladesh. Okay, so the this is the influence line. The frame will show below doing the influence line of YE. So let's see, here is a YE. If we it is push one in Y direction, then the diagram will be like this. It will be pushed upward. It will be 1, and that's why we've been seeing the diagram is like this. So now we will see the YF, and I'm just taking another here. So I'm taking this upward. So we've been seeing here the support. The support will be acting this here, as we have been as we are considering this is the frame. So if we this upward, then what will be happen? As this the support, then it will be goes the acting this like this. So these are the acting like this. Okay, so let's see here BD. Where is the this is the portion of D. So if we using the ruler support is here, what will be happen? It will be going downward and it will be going upward. So the support will be act as here, as I have been said, as we have been considering this is the frame. So that's why the support will be gone there. Support will be gone there. So we are taking the share is here, as the taking the ruler support is here. So it will be going downward. So it will be going downward, and it will be going upward. This portion, right portion will be going upward. So it will be act like this. The support will be must be 0. So this here I'm seeing here that this is the left side, and this is the right side. It will be going down, and this is the support. That's why it will be 0. So VBR SE right. So you can see VBR SE right. So this is the SE. So if you calculating here, I'm just erasing here. So as the frame, that's why the support will be acting here, and this support will be here acting here. So we're just taking the B here. So there is two support, as no the two support is acting here, then it will be fixed up, it will be act as a fixed support. That's why the left portion will be not acting, and the right portion will be gone in upward, while left portion is does not gone in the downward, because the two support is acting. If the two support is acting consecutively, then the support will be act as a fixed support. That's why the right portion is only gone upward. So let's see MD. Uh, where is M? This is the M. So if we now I'm seeing here and taking an internal hinge here and pushing this like pushing here. So the diagram will be like this and like this, as we have been taking internal hinge. So it will be like this. So MB SC, we have been seeing MB. So this is the MB. We have been seeing the internal hinge as support. That's why support will not going to upward, rather than support will be acting like that way. If the moment is acting except than support, then it will be going upward, or it will be internal hinge. Otherwise, it will the support if the hinge is acting the support, then the element will not upward and downward, rather than it will be deflect this like this. Okay, like this. So now we will calculate the same thing, but we are considering the diagram will be like this. It will be rotating in 90 degree. So let's see. Now we will calculate YE. How we will calculate YE? As we know that the YE, if we want to take in one direction in YE, so it will be not going in here, rather than it will be act like this way. So that's why it is being acting this way. Now we are seeing the another is YF. This is the YF. If we push in upward, then the frame will be gone. All the frame will be gone upward is 1 unit. So we've been seeing the all the diagram will be like this way. Okay. Now we will see another, which is BD. If the shear we have been considering here, the cutting this way, so this portion will not going in downward, rather than this portion this portion if we cutting there, then this portion will go in downward. So one unit will be downward, as we have been seeing here the share of BD. So BBSE. So if we calculating cutting here, so the diagram will not diagram does not show the deflected shape. So we have been taking MD. If we are taking the moment is MD here, so we are taking the internal hinge, what will be happen? So the diagram will be acting upward is like this, or like this, as we calculating here, that this will be upward. There is no right side, that's why the left segment will be upward is only. So that's why it's here. Okay, so this influence line is here. Now we'll show the influence line using Müller-Breslau's principle. So before going to the showing the example, I'm just saying that what is the Müller-Breslau's principle. The ordinate, what is ordinate? X, Y, Z. This is the ordinate in any point. In any point, if we founding here, so this is the X, Y ordinate. And influence like any force, like it is reaction, shear force, or a bending moment of any structure are equal to those deflected shape. So you can see the deflected shape is like this or others, obtained by removing restraint. Restraint, that means we have been removing the support. This is called restraint, and corresponding to the element that is introducing its place corresponding the unit deformation of modified structure. Okay, so therefore the unit deflection shape is use the influence line of support, line of the support reaction. So after removing support, I am just calculating the reaction. And unit discontinuity, discontinuity of section, it is used influence line of the shear when after using the inserting a sectional cut. So we have been using the sectional cut like this. Okay, it is going downward and it is going upward. And while rotating and using influence line of the bending moment, so after inserting the internal hinge, so if you push in internal hinge, then it will go upward, and this so it will be act like this. It will be act like this shear, and reaction it will pushing upward, then it will be going there. So three type of we have been seen here. This is the main Müller-Breslau principle. So let's see an example. Here the influence line, this is also taken of Dr. Tukaranam sir. For the frame is shown below, that draw the influence line of XE. So you've been seeing here is the XE. The whole what will be happen in when we acting XE. XE, that means we are taking here in X direction. So what will be happen if we take in here the XE? So XE will be the is the we have been seeing here. This is the pin support. That's why that's why the support is going there, and this is not. This is. It will be acting like this. The all the member is going to the right direction, and it will be acting this, and the deflector shape will be here. Okay, so now we will see the YE, that means vertically. If we take this support in one unit in vertically, then we've been seeing the whole the structure will be acting like this way, so it will also go on there. So so final diagram we have been found like this. Now we will see the another graph, and just taking another here. So VB, so VG, this is the G point we have been seeing. So if we taking the shear, we have been cutting here. So what will be happen? So if we cutting here and pushing in left side in one unit, or right side, that is doesn't matter. So it will be goes here, and all the structure will be trying to go here one unit. So the ultimately diagram will be like this, and unit will be one. And another one, we are taking the V shear, that means V means shear, and the point is D. So now we are trying to cutting this point. Before here we have been cutting the column, that's why we have been pushing in left direction. Now we are cutting this section in beam. So that's why if we cutting here the beam, then what will be happen? If we separate this, then we can see the this structure will be deflected like this. Then another one, if we cutting here, then the structure will be acting like this. That's why the frame will be deflected shape will be like this. This is our final diagram. So let's see another example. So MBSE, I'm just changing color here. MB, here is the B, so SE is this member. So go here MB, this point, as we have been shown the this is the rigid joint. So if we take in here the moment, so there only deflection shape will be this structure or this element. So this element will be acting like this. So MB SE, we have been seeing here SE, where the SE. We've been found this type of deflection will be we will found this type of structure. MD, now we will taking the another MD, last one here. We will taking the internal hinge here, so it will acting like this. So if we taking internal hinge and pushing in upward, then what will be happen? It will be going there. trying to go deflecting, trying to here, and this portion as is a ruler that will be coming from here, as we have been trying to pushing 1 Newton, and it will be acting like this. So final diagram will be like this. We are not giving this program, and final diagram will be like this. Okay, let's see the last example. Here the from is given below from the influence line of xc. X, that means the horizontal c, this is the x. We are pushing 1 in here, so whole the frame will be gone in right direction. So ultimately we will found that this type of influence line. Now we'll show the yc. This is the c point. We've been seeing this is the c point. If we pushing in 1 then whole the structure will be upward, and it will be acting like this. So yc diagram will be no influence line. So we're seeing another which B means shear in F. Here is the F and E. Here is E. So let's see F. Shear is F. So we are seeing shear is F. This is the point of shear. We are just cutting here, and in F. If we shear in F, then if we push in 1 then this structure will be not changed, because this is the fixed. On the other hand, there is no support. That's why all the structure trying to come in, trying to the left section. So all the structure is coming to left section. So you can see here all the structure. So this is our final diagram. So we've been taking shear in E point. So let's see here. Here is the E point. So we're just cutting the member here. So what will be happen? As we have been seeing, this is the fixed support, so there will be no deflected. On the other hand, this structure will be going in upward, so it will be like acting like this. Okay, so let's see the moment. We have been seeing at the C point. Here is the C point in the fixed support. So we imported in hinge at the fixed support. Why important hinge? Because we have been seeing here. For the support reaction, we are removing support. For reaction, we are just removing support and giving answer. And for shear, we just inserting a sectional cut, as we have been seeing here. The inserting sectional cut. For bending moment, just inserting an internal hinge. This is the principle. That's why we are using we are inserting hinge here. So after inserting hinge here, so the structure will be deflected like this, as there is no such support, as the support free. That's why it will be acting like this. Is the final diagram. And last one, we've been seeing the moment in E point. So we're taking the moment is E point. This is the E point. So after if we taking the E point and inserting the internal hinge and pushing this like as we have been seeing, the left section is fixed support. That's why left section will be not deflected. Otherwise, we have been seeing the and this side, this section will be acting like this. And we'll just taking this point. This will be our final diagram. So I think this is our class in depth. If you have any question, then let me know. I'll try to give you an answer. Thank you everyone. Thank you.